According to NEC Article 250.104a, all metallic raceways, enclosures, and equipment must be effectively bonded together into the grounding electrode system. When replacing an electrical panel, several bonding requirements apply. The conduit system must be bonded to the grounding electrode system at both the main service panel and the subpanel, where the panel is being replaced. This can be achieved using bonding jumpers or ground rods. The rigid mass must be bonded to the grounding electrode system through the grounding bushing inside the meter base and the locknut on the outside. The meter base must be bonded to the grounding electrode system through the bonding bushing on the inside and the locknut on the outside. The subpanel must be bonded to the grounding electrode system through the locknut on the outside and the bonding bushing inside the panel. A number 4 bonding jumper should be used to connect the meter base to the panel. If any additional metallic enclosures or equipment are present, such as junction boxes, these should also be bonded to the grounding electrode system. All accessible metal conduits, boxes, and cable armor within the bonding conductor range, typically 5 feet, must be bonded. The absence of a concentric knockout used to set the mast and nipple is not a violation, since the bonding connections are made through the bushings. Smooth surfaced fittings are allowed only on the load side of the service equipment, which is not the case here. However, since the existing installation has passed inspection, it is not required to be brought up to the current code requirements. Bonding is an essential part of electrical safety, ensuring that all metallic parts are at the same electrical potential, minimizing the risk of electric shock. Grounding, on the other hand, provides a path for fault current to flow back to the source, allowing overcurrent protection devices like circuit breakers to trip and de-energize the circuit. In the context of electrical installations, the grounding electrode system typically consists of a ground rod, metal water pipe, or concrete encased electrode, all connected to the service equipment. Bonding and grounding work together to create a safe electrical system. The grounding electrode system provides a reference point for the electrical system, while bonding ensures that all metallic parts are at the same potential, reducing the risk of electric shock. When replacing a panel, it's crucial to maintain the integrity of the existing bonding and grounding system and to make any necessary upgrades to meet current code requirements. Bonding jumpers are used to connect different metallic parts of the electrical system. These jumpers are typically made of copper or aluminum and are sized according to the size of the service conductors. Bonding bushings are used to bond conduit to enclosures. These bushings have a sharp edge that bites into the metal of the enclosure, creating a good electrical connection. Locknuts are used to secure conduit to enclosures. These nuts are tightened to ensure a good mechanical connection. Ground rods are used to provide a connection to the earth. These rods are typically made of copper or copper-clad steel and are driven into the ground to a depth of at least 8 feet. The grounding electrode conductor connects the grounding electrode to the service equipment. This conductor is typically made of copper and is sized according to the size of the service conductors. The main bonding jumper connects the grounded conductor of the service to the equipment grounding conductor. This jumper is typically made of copper and is sized according to the size of the service conductors. The equipment grounding conductor provides a path for fault current to flow back to the source. This conductor is typically made of copper or aluminum and is sized according to the size of the circuit conductors. The NEC, or National Electrical Code, provides detailed requirements for bonding and grounding electrical systems. It's important to consult the NEC and any local amendments to ensure that electrical installations meet all applicable requirements. Understanding bonding and grounding is essential for anyone working with electrical systems. By following the NEC requirements and using proper techniques, you can help ensure the safety of people and property. The grounding electrode system must be installed in accordance with NEC Article 250.52. The grounding electrode system must be connected to the service equipment in accordance with NEC Article 250.64. The equipment grounding conductor must be installed in accordance with NEC Article 250.130. Bonding must be provided in accordance with NEC Article 250.92. The size of the bonding jumpers must be in accordance with NEC Article 250.102. The grounding electrode conductor must be sized in accordance with NEC Article 250.66. The main bonding jumper must be sized in accordance with NEC Article 250.28. The equipment grounding conductor must be sized in accordance with NEC Article 250.122. All electrical equipment must be listed and labeled in accordance with NEC Article 110.3. All electrical work must be performed by qualified personnel in accordance with NEC Article 110.11. Electrical inspections must be performed in accordance with NEC Article 90.4. The purpose of bonding and grounding is to provide a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices such as circuit breakers and fuses to quickly trip and de-energize the circuit. This minimizes the risk of electric shock and fire. Effective bonding and grounding also help to reduce electrical noise and interference, which can affect the performance of sensitive electronic equipment. Properly installed bonding and grounding systems can improve the reliability and longevity of electrical equipment. The NEC provides specific requirements for the materials, installation methods, and sizing of bonding and grounding conductors and equipment. These requirements are designed to ensure that the bonding and grounding system is effective in protecting people and property from electrical hazards. The NEC also addresses specific bonding and grounding requirements for different types of electrical systems, such as those found in healthcare facilities, industrial plants, and agricultural buildings. These specialized requirements are designed to address the unique electrical hazards present in these environments. When working on electrical systems, it's important to follow all applicable safety precautions, including wearing appropriate personal protective equipment, such as gloves and eye protection. It's also important to use properly insulated tools and to energize circuits before working on them. Never work on live electrical equipment unless absolutely necessary, and then only with the proper training and equipment. Always double-check your work to ensure that all connections are tight and that all bonding and grounding requirements are met. If you're not sure about something, ask for help from a qualified electrician or electrical inspector. A thorough understanding of bonding and grounding principles and practices is essential for anyone working with electrical systems. By following the NEC requirements and using proper techniques, you can help ensure the safety of people and property and improve the reliability and performance of electrical equipment. Remember to consult the latest edition of the NEC for the most up-to-date requirements and to stay informed about changes in the electrical code. Continued education and training are essential for staying current with the latest electrical safety practices.